Hi, I'm Emma, and welcome to my channel. In the last video, we learned that variables are places to store data, like numbers and letters. Now let's do something with those numbers, with operators. Operators are just symbols in code that tell the computer that it needs to perform some sort of operation on the data inside one or two variables. There are about 6 categories of operators in Java: assignment, math, comparison, logical, bitwise, and conditional. Let's talk about assignment first. There is only a single operator sitting in this category, and you've already seen it in a previous video. It's the almighty equals sign. Of all the operators, this is the one you'll use the most. Its job is to take a value on the right side of the expression and store it in the variable on the left side. The second category of operators was probably introduced to you fairly early in school. It's the set of math operators: add, subtract, multiply, and divide. These work pretty much exactly as you would expect. There is an extra one that you might not be familiar with, and it happens to be one of my favorites: the modulo operator. The modulo operator will take two numbers, divide one by the other, and then return the remainder. This is super useful in some situations. For example, if you want to check if a number is even or odd, you can modulo a number by 2. If the result is 0, then it's even. Up to this point, all of the operators are written with a term on the left and a term on the right, but sometimes we have operators that just work on one term. The minus operator is an example of this. It takes a positive value and turns it into a negative value, or negative into positive. We use this when we wanted to invert the joystick values. Since we've talked about assignment and math operators, now is a good time to talk about a group of operators that sort of lives in both worlds. A really common scenario is that you want to take the value from a variable, do some sort of math on it, and then put the new value right back into the same variable. So, for example, let's say you have a variable called loop count, and you want to count how many times that the loop method is called. Using the operators we've used so far, this might look like loop count equals loop count plus 1 semicolon. There are two operators in there, plus and equals. The computer will take the values stored in loop count, add 1 to it, and then store the result back into loop count. Since this is so common, Java provides a shortcut operator that does both in one step. You can just write loop count plus equals 1. This operator takes the value on the right, adds it to the left, and then finally stores the new value back into the variable on the left. Adding or subtracting 1 to a variable has an even shorter version. You can shorten this to just loop count plus plus. If you need to count down, you can write loop count minus minus. Just remember that the 1 is built into these special cases. If you need to add or subtract a value other than 1, you'll need to use a longer form. Our third category, comparison operators, behave differently than all the operators we've seen up until now. For both assignment and math operators, the type of values that go into the operator are the same as the type that comes out. So if you add two ints together, you'll get an int back. But when you compare two numbers, the result is always a Boolean. The first comparison operator comes with a bit of a heads up. It's a double equals. Watch out, because the single equals and the double equals do very different things. The double equals is actually closer to its English meaning. It checks to see if two values are equal and returns true if they are or false if they aren't. This is a good time to mention another gotcha with the equals operator. If you try to use equals with object references, it won't break, but you typically won't get the results that you expected. Remember, like we talked about before, object references actually contain the address of an object. So equals will only be true if the two variables are the exact same location in memory. It doesn't compare the contents at that location. If you want to compare the objects themselves, you would need to use the dot equals method on the object, like this. Hold up. Operator in disguise detected. What is that dot doing there? Special symbol? Check. Something on the left? Check. Something on the right? Check. but no spaces on either side. Curious. Yes, while it doesn't usually appear on most lists of Java operators, the dot operator is performing an operation too. Its job is to use the variable on the left that should contain an object reference and use it to execute the functions that are available for that object. It's also responsible for many of the errors that you'll encounter. If you use the dot operator on a variable that contains null, it will produce an error called a null pointer exception, and will usually cause your program to crash. We'll talk more about debugging error messages in a different video, but just know that if you see a null pointer exception, you're going to be hunting for a dot operator and checking what's in the variable on the left. Okay, back from our detour. In addition to equals, the other comparisons are not equals, greater than, less than, greater than or equal to, and less than or equal to. These work pretty much like how it's taught in school. They take two numbers, compare them, and return true or false. The next category of operators is very similar to comparisons, and you'll use them together often, the logical operators. Again, these also result in a true or false. Not returns the opposite, so true becomes false and vice versa. The AND operator returns true if both the left and right are true, while the OR operator returns true if either left or right is true. Remember that the AND and OR symbols are in pairs. It should always be two ampersands or two vertical bars. If you miss one, you'll accidentally be using an operator from the next category, the bitwise operators. For this video series, we're not really going to talk about bitwise operators much more than to just show you what they look like and tell you that they work with the actual digital bits and numbers. You probably won't need these as much when programming your robot, but if you do, come back to this channel and look for an advanced Java video. Finally, that leaves us with an operator that is in a class of its own, the conditional operator. Because it's the only operator in Java that requires three expressions, most people just call it the ternary operator. It's really just a super compact way to write an if-else statement, but because we haven't talked about what if-else statements are yet, we'll hold off on getting too deep into how ternaries work until the next video. Okay, so that's a pile of operators. To fully make use of them in our robot, we should really learn the logic keywords in the next video. But just so you can see a demonstration of some math operators, we'll use them in a simple way to make our robot a little easier to control. Up to this point, our pushbot has some really simple controls. The further you push the joystick, the faster the motor goes. If you push it all the way, the motors spin at 100% power. At half power, they spin at half power, etc. But you might have noticed that it can be difficult to make small, careful movements at low speed. This is because there's not much distance the joystick can travel before it starts going fast. A solution to this is to square your inputs. Now, this might seem strange at first because squaring a number usually makes it bigger. But remember, the range on our joysticks goes from 1 to -1. That means we're dealing with a fraction. That's where things get interesting. Imagine that your joystick is halfway up. That would be 0.5. If you square 0.5, or in other words, multiply 0.5 by 0.5, the result is 0.25. If we plot this on a graph, it looks like a curve. As you press the joystick in one direction more and more, it starts out slow at the bottom and then quickly increases to full power closer to the top end. But wait, there's a big problem with this. Can you spot it? It works great when we're going forward. But what happens when the joystick returns a negative number? What happens when you multiply two negative numbers together? You get a positive number. Now, there is a way to make this work by keeping track of the original sign of the number and then applying it back to the number after it's been squared, but that uses some functions that we haven't learned yet. So let's try a different approach. If we cube the number, or multiply a number by itself 3 times, it does give a different curve, but it avoids the negative number problem because we're multiplying negative numbers an odd number of times. There is a fancy way of doing powers of numbers, but we can do the same thing using a few multiplications. Below the lines where we initially put something in left power and right power, add this line. Left power equals left power times left power times left power. Don't forget the semicolon. Okay, wow. Maybe we can repeat left power a few more times. Let's read this back and make sure we know what it does. Notice that we don't have to start the line with double. This is because we already declared a variable with this name a few lines above. We don't need to do it again. We can just reuse the variable and put a new value in it. For our example here, we're going to imagine that the value coming in from the joystick is 0.5. Assignment operators work a bit differently than most. The right side is evaluated first. That means it will wait until everything is figured out on the right side before it stores the result in left power, sitting on its left side. So let's start on the right side of the equals first. The first thing is a variable, which we know is 0.5. Okay, what's next? A multiplication sign. That operator needs two numbers, so it will go get the value on its left, 0.5, and the one on its right, also 0.5. Now the multiplication happens, and you can imagine that Java basically replaces this part with the number 0.25. Continuing right, we run into another multiplication sign. And again, we need something on the left, which is now 0.25, and something on the right, which is left power, yet again. If we multiply these two together, we get 0.125. We've now reached the end of the line, so there's no more operations to do. But remember that the equal sign is still waiting. We take the value 0.125 and store it in left power. It's important to notice that the variable left power doesn't have 0.5 in it anymore. It's now holding 0.125. So when we get around to sending it to the motor will only spin at 1/8 of max speed instead of 1/2. Let's do the same thing for the right side speed. Duplicate the line and replace left with right. You can try it out by downloading it to the robot and seeing how differently it drives. Okay, that's probably a good place to stop and get ready to use these operators more in the next video about control flow.